All right, so what we're doing right away this morning is if you still have your e-projects and that 220 project, just go ahead and delete the whole project. Make sure you're out of Power GeoPak. And then go ahead and replace that 220 project with the one from Chapter 6. So Chapter 6 is going to be about building our network. That's where all the calculations of the inverts are going to happen. That's where the depth of the structures are going to be calculated. And that's also where the pipe sizes will be calculated. Yeah, thanks, Chris. I got the recording going now. That would have been bad. So we're just replacing those files that we had yesterday with the ones from Chapter 6. And then what we'll do is we'll go ahead and reopen SS4, and we're still going to be in the DRPRRD. So we're opening the same drawing that we had previously, although this is obviously the one from Chapter 6. We're going to open the DRPRRD01. Make sure that the user and the interface is set to FDOT SS4. No reason it shouldn't be as long as you went in through that SS4 icon. Just like Chapter 5, this one will be rotated, so it's a little more easily readable left to right as far as the stations go. And then to get started here, as we have been doing, we're going to go into the FDOT Plans Development task. We're going to go into Drainage Plans, and the very first icon in there is going to let us open up GeoPak Drainage. GeoPak Drainage should remember our project, so we can go to the project menu, and right down at the bottom we'll reopen that SR61 GDF file. Since Chapter 6 zip files in that project doesn't match our layout as far as the hard drives go, you're going to get a warning about the criteria directory. And that's fine. You can click OK to that and just go to your project preferences and just do a file open. And if you place that file out on your desktop yesterday, we'll have that sr61.dpf file that we can load. If anyone needs that here in class or online, we could get that out to you probably. I would recommend creating a file similar to that if you're using GeoPak Drainage at all in projects. That way you can just open it up for every project and set those preferences and not go through 20 minutes of setting those up or checking those. So I'm going to go ahead and open up the project here and set its preferences. I'll click OK. I may get a warning about shapefiles. I'm not going to reference that in, and I'm going to hit yes to save the preferences. So that puts us back essentially where we were yesterday afternoon. The main difference is if you go to your component and then go to link edit, we now have all the links in it, which I think you probably had those already yesterday. We all put them in manually ourselves, but this is the newer version of it. You can use Windows Center and highlight, and it's going to take you right to that particular pipe, or link as we call them here in the database. If you want the elements to look like what we had previously, so it's easier to spot items, if you'll go to component, and unfortunately we have to do this 3 times. If you go to component area, update all, the areas are going to update to the colors that you had set previously. And then for the nodes, it's a separate pull down. You have to go to component node and pick update all. And then for the links, you have to go to component link and then update all. So I had the areas as red, I had the inlets or nodes as orange, and then the pipes I had as light blue. And you can see that even with the highlight tool, when it's all brown all the time in the file, it's hard as heck to see what the heck anything is. So that's why I updated these areas, nodes, and links. So now we'll go ahead and open up Chapter 6. And Chapter 6 is where all the calculations are done. Before we can do any calculations, though, if you flip over to page 6.3, we're going to have to go ahead and open up and create a network. And if we look, let's see where there's a good screenshot of this. Actually, the best way to do it is just to do the exercise, and I'll talk through it. So as you look on page 6.3, we do not have to do or have already done everything here on page 6.3. We don't have to go through the GeoPak project manager. We've already opened up the drprrd01 file. We've already opened up our drainage project, and we've loaded our preferences. So we don't have to do anything on 6.3, and we can go right here to 6.4. And if you look at our drawing around station about 704 on the right-hand side, we do have a node here and a ditch bottom inlet. They're not connected to anything. And that shouldn't cause GeoPak drainage any problems because there's not any pipes connected to those. But if we had a pipe that went just between this 204 and 206, then GeoPak would probably give us a lot of errors about trying to build the network, because that one pipe isn't connected to anything. It's just sitting out there between these two random nodes that we have. So extra nodes that aren't going to be in our particular network seem to be okay. It's when we have pipes that just don't go anywhere or aren't connected that we run into issues. So I think we're going to be fine building this network. Excuse me. And then to build our network, this is at the top of page 6.4. You're going to go to the network menu, and we're going to say add. We're going to have to give it a network ID. The convention here is we're going to name the network the same as the project and then put a -1. If we had a second network further down the road, literally, that'd be -2, -3, -4. So that's the general convention. Is it's our GDF file name, which is SR61, and then it has a -1, 2, or whatever. And then we do have to tell it what the outlet node is. And there should, in our case here, there's only one available outlet node, which is this S211 out. If that doesn't show up in the pull down, we can click the icon just to the right, and then we could go click on some node, and that little icon lets us pick the outlet node. But usually it's just going to show up in the pull down. And then once you filled that out, you'll go ahead and click OK. And then it's going to take us to our network configuration dialog. And it's going to have at the top a similar setup just like we had with areas, just like we had with the nodes, and just like we had with the links. We have a pull down for picking from multiple networks. We have arrow keys to go back and forth to the different networks. And then on the right, we have these small icons for adding a network. We can delete a network. We can rename a network, and then we can set it as our active network that we're working with. And then before I forget, I did want to take a quick look at the delete tools with the nodes and the links and the areas, just to kind of give you a warning. So we don't want to actually delete anything. I just want to show you this. But if I went to component area and I'm working inside of the area dialog box here, and I decide I want to delete S213, when I click this little delete area button, it does not go out to the area that you're looking at that moment. It jumps to the first one that's in the database. So, and there's no undo on this. So I can't tell you how many times I wanted to delete S213, go straight to here and hit apply, and oops. So be careful with these delete buttons on these dialog boxes across the top. A better way to do this if you need to delete something is go to component, and you can go here to area, and I can go straight to delete. And then at that point I kind of know that I have to pick and tell it which one to delete. So on any of these, whether it's area, whether it's node, if you're in that edit dialog box, when you click that delete button, it's going to just default to whatever the first item is of that type. And if you're not careful, it's going to give you some problems. All right, so now we've got our network, this SR61-1 network. And this icon, or this dialog box, has a couple of different icons. The first icon here is to build the network. So the building of the network does not necessarily include the calculations. You'll see a note here in the middle of 6.4. But if you click Build Network, it's going to tell you that the network is successfully built. You're going to have total nodes in the network are 14, and then you're going to have total links in the network 13. So the number of links is always going to be one less. So all that does is check the connectivity of everything. It's not performing any calculations. But it's not a bad idea to click that Build Network first, because that's going to let us know if we have any problems or any issues with stray pipes and other types of items. So we had, and if you hit it 5 times in a row, it doesn't matter, it doesn't hurt anything. So we've got 14 nodes and 13 links. So if I went out here and I looked at the nodes, so I did component node edit, we'll just count them. So I'm starting here at S200. We might as well use the Windows Center and the highlight. I've got 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That should be 14. You can see it doesn't include, should not include these guys down here. We could kind of check that. So right now when we build the network, we have 14 nodes, 13 pipes. So let's just see what happens if I go out here and delete 204 and 206. See if we get a different number there. Because maybe this is something we should be more careful of. So I'm just going to say component node delete. And I'm going to delete S204. Hit apply. You do get a warning. So if you do accidentally pick the wrong one here, you can back out. This says it's going to delete drainage node S204. Click OK. It's gone. I'm going to delete 205, or excuse me, 206. And I'll rebuild that network and see if we end up with a different number. And we don't. So I think you're safe if you wanted to lay out every inlet in the entire project and then just connect the pipes to the first network, you would be perfectly fine. It's not picking up any of those stray inlets that are sitting around out there. Where it would probably give us problems is if we had a couple of nodes out there and a pipe that just didn't connect to anything. That would be where you would run into some issues. All right, so our network built fine. That's the first button here under validation. 14 nodes, 13 links. And then the next button is going to let you highlight that network. The highlights on these they're not real solid. It does highlight these pipes and it highlights the nodes, but it's really hard to pick up for me. You might be able to adjust that by going to Workspace Preferences, and there is an option here. It'll take me a minute to find it. Let me adjust this. Probably the last one. Yeah, it's under the dynamics transparency. This part, these sliders here, might make the highlight a little bit darker. I'm not sure if it'll work or not. Yeah, it does. So now you can see it a little bit better that this is highlighted. Once you highlight it, you're stuck with it being highlighted until you close out that dialog, and then it'll go ahead and release it. So once it's highlighted, it'll just stay highlighted. And we'll go back into Network Edit here. And then you'll see that we match up what we have on 6.4 Step 5. We had 14 and 13. Top of 6.5, you'll see what we just demonstrated, which is highlighting the network. Once you highlight it, it does stick there until you get out of the dialog box. And then if you look at step 7 here, there's 2 options under computations. And there's a real important difference between the 2. So there's design network and analyze network. And let me make sure I tell you the correct configuration here. So I'm going to make sure that if you look back on page 6.3, this one might be worth noting. Design does all the hydraulic design of the components. It checks the current network, and it designs any features. That's the one that's going to change the pipe sizes. So design is actually going to design the network and potentially change the pipe sizes. The button on the right-hand side of that under computations, which is analyze, and I'm reading this right from the top of page 6.3, it looks at all the components as they are, and it just maintains all of the pipe sizes and whatever number of barrels that you happen to have. And usually it's just one barrel. It's usually one pipe in between the two nodes, unless you have some minimum depth of cover problems. So design, which is the left one underneath computations, that's the one that you see here highlighted in 6.5. Step number 7, that's the one that's going to change the pipe sizes and actually design our network. The one to the right of that, which is analyze network, that keeps all the pipes, it basically ignores all the design toggles, and then goes ahead and just looks at the network as it is. So if you were to hit analyze, and it'll still build a network, you'll get some error computing hydraulics for the network, and then it's going to give you some error messages. So analyze is just going to look at it as it is, and it's going to produce some error messages. Doesn't change any pipes, doesn't try to put in multiple pipes if you got the barrels toggle put on, doesn't touch the size of anything, doesn't do any actual design, just analyzes the network. And if you click the design button, it's going to tell you the hydraulics was computed with warnings. It's going to tell you how many nodes, how many links. And then when you click OK, this is going to perform all the analysis, and this is the one that's going to give you all of the different warnings that you might have. And most of these warnings, actually almost all these warnings, they come from how we had the links set up previously. So you're going to get a lot of warnings there. We're not going to fix all of them, probably won't fix hardly any of them, but where these warnings are coming from, such as link pipe 200 velocity less than minimum, link pipe 209 velocity less than minimum, computed ponded width for inlet S203 exceeds maximum, where these warnings are coming from is way back when we have the links. We had some constraints for these links. So on our links here, we had the constraint for the maximum and minimum pipe size that it would try and use. We had minimum and maximum settings for the slopes. And then we had minimum and maximum settings for the velocity. So that's where those are coming from. So almost all those warnings that you're seeing when you click Design Network, they're coming from those constraints on the pipes. Now, if those constraints, and they should be coming from the design manual. If those are correct, then we'd have to go in and we're going to have to adjust the invert elevations on those pipes. We may have to adjust the elevations on the nodes. But most of these warnings that you're seeing here, they're coming directly from these link constraints that we put in earlier, or were put in yesterday. And now if you were to look at any of the links under computation, it has all that information now computed. So we didn't have that yesterday. You don't have any information in computation here on the links until we build and design or analyze the network, actually design the network. Just like yesterday for our nodes, we didn't have any computations until we added the area, and then we could figure out how much flow each node had. So if you go back and take a look at any of your links by going to Component, Link, and then Edit, if you go to Computation, you should see that's all now filled out. If you go to Conditions, that's where we can make adjustments to these. So it's now calculated the minimum cover, it's calculated the invert, it's calculated the maximum depth, it's got the invert at either end. And once we get to the, I think it's the next chapter, we'll have a really good, nice profile way of viewing and looking at these elements. And we also can adjust the inverts of the inlets graphically instead of just making changes here manually. But anywhere on any of these links as you're trying to go through, or someone is trying to go through and fix these issues here, anywhere you've got a check mark, that's going to be an area where you can change items. So I could lock the soffit, I can lock the invert. You can't have them both checked. You have to uncheck one and then check the other. But anywhere you've got a check mark, you can go ahead and lock in things like the slope. You might have to uncheck check marks to the side. If I'm going to modify the slope and lock in some different number here, I'm going to have to uncheck the inverts, because obviously the inverts have to move in order for the slope to change. But anywhere you've got a check mark here in the link configuration, the conditions, you can lock in and tweak and change those numbers, and then you can redesign the network and see if you get more errors, hopefully not, or if you get less errors and less warnings. Same thing is going to happen with your nodes. Let's see if, first of all, let's see if I'm telling you right. This should be an 18-inch pipe, I believe. So let's see. Oh, actually, this one's 30. So let's see what we've got here. We've got conditions, and then we've got an invert of 26.1. And we've got a soffit of 28.6. Divide that's 30 inches. Yeah, the soffit's the top of the pipe. Which, I don't know, a lot of people, I don't know why we need that. So, but it's the top of the pipe. So if you take the invert minus the soffit, you're going to end up, I ended up with 2.5 feet, which is 30 inches. Yeah, so that's what the soffit is. And any of these conditions you can check on and modify them. What I would recommend is, and you can do this with the nodes as well. So the location for the nodes, the node, the thing you change with the node would be the elevations. So you can say elevation source is user supplied, and you can just lock in that number if you want to. What I would recommend, if you're troubleshooting or working with someone that's trying to troubleshoot one of these networks, what I would do is I would try and just take these warnings, I'd try and just take them one at a time. What you're going to run into is this message that's created. You're going to see it goes out into the drainage folder, and it creates this drg.msg.txt file. Every time that I redesign or reanalyze the network, I think either one goes to the same, yeah, they go to the same file. So anytime that I click these buttons underneath computations, this file is overwritten. So what I would do if we were debugging and tweaking this network here, what I would recommend is just take one of these at a time that you're trying to solve. But before you exit out of this text editor, I would do a file save as, and maybe add a number to it so you don't lose it. So I would save this as drainage message 1.txt, go in and tweak one of these pipes or nodes and try and fix the problem, and then run that design process again. That way you'd have steps all along the way to see if you ended up with more or less problems. Because every time we recalculate this, we end up with overwriting this drainage message file. So I would not be in the habit of just, oh, I've got errors, and go out and change 5 things and run it again, unless it's something that's just real obvious and real easy to fix. All right, so we've got some warnings. I definitely would save that file incrementally 1, 2, 3, and 4, and we could go through and fix those issues as we went through the network here. That way we kind of have an audit trail. So if you go ahead and click, no, you've already clicked design. That should have went through and designed all of these pipes. Now I did not look at each and every pipe that we had as far as the sizes, but I think what you're going to find is they probably didn't change size. I think as we unzip the Chapter 6 files, we can check them. So 201 is 18 inches. Yeah, none of these would have changed size. And the reason I know that is as I click through and look at these different links, none of these have design size checked on. So if you look at, for example, just had it a minute ago, 207, it has it as 24 inches. 208, it has a 66-inch pipe. 30 was the pipe 211, and I think everything else was probably 18. So if you don't check on design size, those pipes won't ever change size no matter how many times you analyze and tweak the network. So if you go back to your network dialog box, if you look over on the right-hand side, that's why you have these buttons for locking sizes. You have unlock sizes, and then you have lock elevations and unlock elevations. And the reason you have that is so you don't have to go in here and go into component node edit and unlock the elevations for every node, and you don't have to go into component link edit and go in and check design size for every pipe. So what should happen if you go back to your network dialog here by going to network and then go to edit, if you'll click unlock sizes, what it does is it's like we went into each link and went into edit and checked on design size for each one. So if you've got 20 pipes, you don't have to go in there and check that and hit apply 20 times. The thing that's a little confusing is maybe the terminology here. When I click unlock sizes, I tend to think of it as unchecking something, but it's not. It's actually checking design size. So that unlock sizes, that kind of makes sense, but maybe design size should say let size change or something. But that'll go through when you click unlock sizes. That's going to go through and check design size on all of these and do the equivalent of hitting apply. If you click unlock elevations, it's going to go into, I believe, your nodes, and none of the elevations will be locked, and it's going to go into the links, and then on the conditions, all these check marks here are going to be cleared. Now, if you had went in previously and you checked on a few elevations and changed and tweaked them to get it to process a little bit better and get rid of some of those warnings, you may have to go through and go back to those and individually check them back on and put in those elevations. Because these buttons here, they're going to do it for every pipe that you have, not just a single one or two. So if you make sure the sizes are unlocked and the elevations are unlocked, and then click the first button under computations again, it's going to go through and rebuild, reanalyze the network. You're going to end up with a lot less warnings. And we should be able to go back to the links and see that the pipe size has changed. So I should be able to go back here to my component and then go to my links and edit them. And you can see 211 was 30 inches. Well, now it's 18. One of these, I forget which one, was a 66-inch pipe. There's no more 66-inch pipe. Looks to me, I'll start back at 200. Looks like I've got 18 on all of them. Haven't seen anything change from 18. Now, if you're trying to, maybe one of the pipes that you're tying into is an existing pipe. So you may have to, on your actual project, you may have to go in, if it's an existing pipe, you may have to click unlock sizes here to get 19 of the 20 pipes unlocked as far as size goes. And then you might have to go to the 20th pipe that's an existing pipe and just uncheck design size and hit apply. So I'm not saying that you won't have to sometimes scroll through all the links in the network, but if it's an all or nothing type of deal, then these buttons are designed for that. And I have seen cases where we keep design size checked. I unlock all the sizes, I run it, and I have seen cases, and I've done this, where I went back and looked at the links again. They shouldn't have changed, and they did. I have seen it be inconsistent with analyzing these sometimes. But some good ways to check it. If we go in and I pick some ridiculous size for a pipe and hit apply, so I just said pipe 207 is 90 inches. I know that thing's got to change. So I've unlocked all the sizes. I redesigned that network. I would certainly expect pipe 207 to change that diameter. So here's 207, it's back to 18 inches. I have seen this many times where it doesn't seem to work correctly, and you do have to double check it. The one that I've had a little bit of trouble with, and this is not a great network to try this on because they're all defaulting to 18 inches. But what I've also tried to kind of make sure things were working before is, take a particular pipe like pipe 200 and go in here on the constraints and say that I'll let it use a rise from up to 1 foot up to maybe 2 feet. And went in and kind of played around with this design barrels option. So I would uncheck design size, and I'd force it to be a 12-inch pipe, but I would let it design the barrels. That one I've had a little trouble to get to work. And it may be that maybe the 12-inch works. Maybe it's good enough. But we know it calculated out to be an 18-inch pipe. So I would think I could probably end up getting it to put in 2 12-inch pipes. But I haven't done the profile and haven't looked at it. It may be that the 12-inch pipe ends up working fine. It's just absolutely completely full, and maybe that 18-inch was not completely full. So I'll give it a try though. So I've got the size unchecked, so that should keep the size at 12 inches, and I'm telling it to design barrels, and I think you have to, let's see what happens. So let's check design barrels, see if I can get 2 12-inch pipes to come in there. And it may not work. We'll give it a shot though. So I'm going to click apply. I'll close out of that. I'll close my text editor, and then I'm going to go ahead and redesign that network. And then we'll go back and look at that particular link. Yeah, it didn't change. So I think you might have to toggle this on. You might have to pick how many barrels up to you want it to be able to place. So I'm going to try something like 10 here. See if we can get that to change. That one, in general, I've had trouble with getting the design barrels to work. but that's only been with this particular data set. It may just be that a 12-inch pipe happens to work there. Yeah, it probably does. It probably does. But if you had some pipe, and I don't think we ended up with any that were over the 18-inch size. If we had one of these that calculated out as we went through and we looked at these pipe lengths, and I went through here and found one that was a 30-inch pipe, that one you probably could get the design barrels to work with. I've not generally been able to get it to work with this data set here. They all tend to calculate out to all 18-inch pipes from what I've been seeing, which like I said, I have seen this be inconsistent. Usually, as I recall, because I've looked at this quite a few times, usually that pipe there, the 211, ends up being about like a 30-inch pipe. So I'm not sure why it's calculating out to 18. So we'll take a look at the chapter 7. Let's see what the pipe sizes are there. Really what you need, what's easiest for me to check on these is what's going to happen in the next chapter, which is chapter 7, which is creating the profiles. The best way for me to look at these is you're going to plot the pipe, you'll plot the hydraulic grade line, and you want to see where that hydraulic grade line falls within that pipe. So what may be happening, I don't know if we have any, well, we don't have a whiteboard, but what might be happening, oh yeah. Do we have pens? That's the next thing. Yeah, we got pens. That'll work. Bold color, dry erase. So what might be happening with that one pipe that's not changing is for the 18-inch pipe, the hydraulic grade line might be like here, about like in the middle of the pipe, where it's only half full. But maybe the 12 works because with the 12, the hydraulic grade line is a lot higher in the 12, but it's still good enough for the capacity. That might be what's happening. It also could be that this is not working consistently, because I have seen that. I saw someone, it was at USF where I went to college, there was a change in the class, the class time or date, and there was a screen about 5 times the size of this, and someone had wrote on it with marker, class has changed and moved to such and such. Probably ruined a $5,000 screen. Like, oh no, these are the people teaching me? So I always make sure it's dry erase. So let's take a look at chapter 7 here and see what they ended up with. For those of you online, what I was drawing on the whiteboard was that 12-inch pipe may be working. It's just that it's a lot more full than the 18-inch pipe. That may be why it didn't change that pipe size. But we'll take a brief look here at what they have in chapter 7 just to see if they have a little bit different results. Because I would expect, that this pipe here would be larger than the 18-inch pipe. So I'm going to go ahead and open up, and you don't have to do this. We just want to take a quick peek at it. I'm going to open up the SR61 GDF file for chapter 7, and I'll just go through the motions here. I'll set my preferences. And let's just see what pipes they ended up with as far as their size, assuming that everything was done correctly when they did chapter 6. So if I go here and I look at my links and I edit the links, we'll start off at 200. That's 18 inches. No, it looks like we got the same results. So I would say those 18-inch pipes appear to be correct. What we'll do when we get into chapter 7 is we'll plot some more profiles than they have in chapter 7. We'll plot us a profile here from 211 to 211 out, put the hydraulic grade line on it, and see what's happening there. So I think that'll help us analyze it a little bit better. But it looks like in Chapter 6 that we did go ahead and have the correct configuration there. All right, so if you look on page 6, 7, I'm just going to stick with the Chapter 7 zip files because I already have those. Let's see if we, looks like we might have a question out here. No, these are old questions, so bear with me for a moment. Let's see if we can pop that out. Oh, okay, yeah, I'm sorry, there's a question or a comment here. Yeah, see, yeah, the velocities in S211 were exceeding that maximum. It may be too steep. So let's take a look at that pipe there. Chapter 7 should be the same as the Chapter 6 files that I had. And hold on a sec. Let me see if I can configure this question window. There's a little, I think I have to, oh, here it is, pop out. Sorry, I apologize. I don't use GoToMeeting often. Yeah, so I think you're right there, Ricardo. Let's take a look at the slope of that pipe. So go here to Component, Link, Edit, and our guy here, 211. Freeboard. What was I'm going to go back to that report so we can just pop it right up on screen. Yeah, it's great. So it's greater than that 10%. Yep. And what we could do to fix that, well, this could backfire, but I could go in here and take a look at that S211, and then that's where we can go in and adjust some of these conditions. It's a pretty, what's the length of this pipe here? It's only 27 feet, and it's dropping, there's the invert here, it's dropping like 3 feet and 27. So let's lock in an elevation here. Let's make this not quite as steep. We've got about 21.5 at the outlet for the invert. So it's 24 here. Let's make it 22.5 here. So it's dropping a foot over 30 feet. So that's going to lock in that elevation. I'm going to click Apply. And then I'm going to go and redesign that network. That elevation is locked. It should stay locked. Still getting velocity greater than desired, but let's see if that pipe changed size at all, that S211, or that pipe 211, excuse me. Still 18. Let's see if that elevation stayed locked. Oh, it recalculated the elevation. So let's see if we can lock both here. And let's knock that down to 20 and see what happens. So those should stay locked. They don't always stay locked when it redesigns the network. They will move somewhat. Let's see if we're still getting still got velocity greater than the maximum desired there. Let's see if that pipe changed though. There's 211, still 18 inches. Did it change my conditions? It did lock them in this time. And we probably would have to back up through the network too and maybe adjust that. But definitely right that that pipe 211 may be why it's stuck there at 18. So once this network here is calculated, you do have the option here just to the left of the Apply button where it says Set Active Network. The whole time we've been working so far, we've had at the top of our drainage menu, the drainage project, which in our case was SR61 GDF. It's always been saying no active network. So now that we have a network, if we click the button just to the left of Apply, that's going to set that, or let us pick and set that as our active network. So now it says SR61-1 active. Now that's the only network we end up doing. It's the only network we end up with in any of the zip files. So it's the same network all the way through. But once that network is active, we can go here in step 3 on page 6-7, and we can look at some drainage reports. So this is another tool besides the next chapter, plotting the profiles, that's going to let us help and know what to adjust to get rid of a lot of those warnings, or at least understand that, why the warning is happening, and decide that we're okay with that warning. So if you go to your reports tool here, you can either use the dialog, so there's a toolboxes, reports, where you have this toolbox that you see here in step 3, or you can go to reports, and there's quite a few reports that you can build there. If you look at the toolbox though, you're going to have drainage area reports. These will all export out to ASCII files. So you can export all these. And it lets you pick all networks or active network, which is for us is the same. It does give you a little spreadsheet look here where you can window center and highlight. And then the next report is the node report, the sump. That one's not going to give you anything on this one. The third one is the on grade. All of ours were on grade. That's going to give you a report on all of these. And then you have a report for the configuration. That defines or has the definition of all our pipes and the sizes, the shapes, the rise, the slope, the invert. So here's our S211. I'm surprised it's complaining on I keep on at S, but it's pipe 211. It's got a slope of 6.5 in percent. And the warnings we had set it up was over 10%. You will see the 212 is 10%. And then you've got the link report for the computations. And then you also have a couple of ones that we'll look at separately in some separate chapters. So I think all of these, let's see how we can get these out. One thing you can do on all of these reports, if you select a row, and this is a real easy little icon to miss, it's right down there at the bottom above the magnifying glass. It says modify items. So if you click on a row and you click modify items, it's going to take you to the edit tool for that particular element, whether it's a link or a node. Probably would do that if you, let's see if we double click. Double clicking will not do it. You have to click on this and highlight, and then click the modify items tool. And then let's see if we can save an ASCII file here. Let's see exactly what these allow us to do. Let's see what these look like. So I'll put that in the drainage folder. Save it. It has an odd extension. So the extension to these files, at least the one that I just did there, was SUM. Or at least the one I thought I did. Let's make sure that did save. Not sure. So I'm not sure if you have to highlight them. I'm highlighting them. I'm going to go into, maybe I put it on the C drive. No. Go into drainage. I just called it test. I'm clicking save. Save and then apply. And then we'll look in the drainage folder. Yeah, you got to hit. That's not very intuitive. And Windows at first is not going to know what to do with an SUM file. It should open up fine in Notepad. So that would also open up fine in Spreadsheet as well. You could do a space delimited, it'd work perfectly fine. I do not think this will, it does have an edit. Let's see if, Edit will just take you to the SUM file. So it does not have a facility for changing that text file and then reading it in and editing those elements. So there's not a link to edit those. If you wanted to edit the items, you would have to click on each one individually and then click Modify Items. And then it takes you to this editing dialog box. What we're going to see in a couple of chapters, though, is we'll see there's a global editing tool that's a lot more friendly than doing it the way that we did the nodes and the links in the areas. We'll have a better way to show you that in just a little bit. All right, so I think that network is pretty good. We're going to borrow the Chapter 7 files in a few minutes anyway. What you would need to do workflow-wise is you would need to analyze this report that's coming out of here. It always saves it as this drg.msg.txt file. And what I would recommend is I would go in and I would start trying to fix these one at a time, try and make minimal changes and recompute the network. But make sure that before you close out of the messages here to do a save as, because every time you recalculate, every iteration where you recalculate that network, this drainage message without a number on it, that's going to get overwritten every time. So I would start off by doing drainage message 1, go ahead and start making some changes here to pipe 200 where it has less velocity than desired, so we need to give it some more slope. Recompute the network, see if that warning goes away, and then just move to the next line and keep knocking them off one by one. Now you might end up with 10 of these drainage message files out here in the drainage folder, but that's fine. That's not going to hurt anything. At least you'd be able to backtrack your efforts there. All right, so let's go ahead. We'll take a quick 10-minute break here, and then we'll jump over to Chapter 7, which is our drainage profiles. That's going to give us a good look at the network as well to be able to plot that hydraulic grade line. And we also have a tool in there that's going to let us plot miscellaneous utilities on top of that profile. So if you would, do as we have been doing. Go ahead and close out of SS4, and then we'll go ahead and extract the files for Chapter 7. And then we'll reopen SS4, and we'll be back in our DRP-RRD file. So it should remember the file that we were in. It's going to be the DRP-RRD01. We'll go ahead back into our FDOT plans development, and then we'll go through the first icon here to open GeoPak Drainage. Does not automatically reopen the last project we were in, but if we go to our project menu down at the bottom, we'll have the last project that we've used, which is SR61. We'll reopen that project. You're going to get a criteria warning. You'll click OK to that. And then, as we've done before, you'll go to Project Preferences. And then you're going to open up the preferences file we saved yesterday out on the desktop or whatever the convenient location was for you. Now, the way I set it up, since I did use the super elevation shapefile, I'll get a message about it's not attached as a reference. I'm just going to say no. It's going to tell me it didn't attach it as a reference. I'll say OK to that, and then I want to make sure to hit yes to the drainage preferences message. So on the drainage profiles, this is going to let us plot a profile between any two nodes in our project. So it's going to let us pick a from node and a to node. And then whatever other nodes it happens to go through that are interconnected between that from node and the to node, those are also going to show up on the profile. So back to what we were doing just a few moments ago with the network analysis, I'll go ahead and set the active network to our SR61-1. The tools that are going to let you help troubleshoot or help someone troubleshoot in some cases the network issues. One of the best tools is going to be back on our network dialog box under computations, this analyze network. So if you're helping someone out or you're doing your own analysis, use that analyze button. that's going to go through and compute the network and give you these warnings. But it's not going to change any of your elevations. It's not going to change any of your sizes. And then what you would want to do is I would just start with these one at a time. If I've got a pipe that has less velocity than I've desired it to have, I can either make that pipe a smaller size, I can give it more slope. I'm going to have some that exceeds the maximum velocity. Those are ones that I can go ahead and decrease the slope of the pipe. I would just take these messages, go through them one by one, and then just save them incrementally as you go through and analyze and work with the network. That way, if you needed to, if you end up making a change that gives you some issues, you can go back to one of your previous drainage message files and undo those changes. There's nothing wrong with saving multiple GDF files. If you want to save multiple GDF files, you can always do project save as, and you can save it as SR61 A, B, C, D, whatever version. That would give you somewhat a way of backing up or undoing the changes and such. And then also we had toggled on our drainage preferences under the save options. We also had the automatic backup. I'm not sure what extension that file has. Let's see if we can maybe find one out here. I'm not sure what the automatic backup file extension would be. Let's see if we happen to have one that's sitting out there. And I'm not sure that that automatic backup doesn't happen maybe only when it crashes or has some kind of issues. Actually, it's right here. There's this sr61.drg, this LOC file. I think that is your backup to reopen the project. But if you want something that's a little more direct, nothing wrong with doing a project, save as, and save a variety of SR61 GDF files. That at least is going to give you a little bit of an undo capability. Now when you move, eventually you move to the SUDA and the open roads type of technology, the database at that point is not a separate GDF file. The database is the DGN file, which means you can undo all you want to and redo all that you want to, and you have a lot more flexibility there. But that's not the case that we have here, so nothing wrong with saving multiple project files. All right, so we'll go ahead and we'll take a look here on page, it'll be page 7-6, and we're going to use this to walk through and step through all the different screenshots we have on those previous pages. So all of these chapters, if you haven't noticed already, they're set up with all the information about the particular exercise that we're going through as screenshots on the first few opening pages, and then we get into the exercise and we end up looking at those same exact screenshots again. So the most efficient way to do the class tends to work out time-wise just to go right to the exercises, and if we need to explore one of the dialog boxes a little bit more, we can do that. But just as a disclaimer here, just because we're jumping right to the exercises doesn't mean there's not good information in those previous pages. In addition, there is a whole chapter, which is our chapter 20, that has some of the calculations that are used. It's called the technical reference. It has some of the calculations. It has a breakdown of the different drainage warning messages, and that's all in chapter 21. So chapter 21 gives you a breakdown of some of the drainage warning messages. So there's a lot of good information in chapters 20 and 21 as well as those lead-in pages to our chapters. Here on page 7-6, you're going to see there's opening the drainage project, and you're going to see those same steps that we've been going through all along. We've opened up our DRPRRD01. We don't need to do the GeoPak project manager step in step 2, 3, and 4, or 5. And we've already opened our drainage project, and we've set our preferences. So really all of these chapters the first part of the exercises in all of them, if you happen to go back and review any of this, you can just flat out skip. We have not needed that part and haven't been doing it. So we're going to go straight here to about the middle bottom part here on 7.6 where it says creating a drainage profile. So the drainage profile itself, it's considered a component. We're going to say component, we're going to say profile, and we're going to say add. Now it's going to call that PRO-1 because that was set up in our preferences to start the naming convention for our profiles. We'll change this to be profile-200 or pro-200. And it's going to let us pick the from node, either from the pull down. The from node will be S200, and the to node is going to be all the way to our S211 out. If you don't want to pick from the pull downs, you have icons just to the right, and it lets you go and pick the from node and the to node. So we'll probably create one in a little bit that goes from this S212 out to the S211 out. We'll take a look at that pipe and see if there's anything odd going on with it. But for now, to match our exercise, we're going from S200 all the way through S211 out. And then you're going to click apply, and you're going to see this pretty complicated, almost scary dialog box that you're going to see up here on the top of 7-7. And we'll look at all of the items that are in the exercises, and we'll look at a few additional items as well. A couple of main things to know about the dialog box here are outlined in step number 4. So there's two methods to place this drainage profile. One is to click the DP button and then go out and click on screen where we want the profile to be plotted. So if we're just plotting a profile and we're using it for some analysis, then we can just go in here and we can just plot it anywhere on the screen that's convenient for us by using that DP button. The other option here is the second check mark you see under step 4, and that will allow us to plot it on top of an already created profile. That one's probably going to be the more useful one as far as planned production goes. Now, I don't recall if we have in our roadway folder a profile file. Let's take a look. We do not. Later, we will get one of these and take a look at it. But if we had in the roadway folder a DSPF RD01, a profile drawing, we could go into that profile drawing, and I don't think we have one in drainage either. No, we don't. But we could go into that profile drawing, and back here on the profile tool, and I have to, once you create it, you can't do add anymore, you have to do edit. So I'll have to get back to my Pro 200 here. If you do project to chain, this identify profile cell button is going to light up, and you can go and click on that profile cell, and then it'll plot it on top of that roadway profile or whatever other profile is already existing out there. So that button's going to be a real handy one. I believe later we're going to have a roadway profile file that we can borrow from one of those zip files, and we'll go back to the profile tool just to show you how to work with this identify profile cell button. But those are the two ways to be able to place our profile. Now, they don't give us a whole lot of information here in step number 5. It just says set up all of the other tabs to display the profile as desired. It doesn't really tell us what to set, so we'll just go through all of these. So first thing I'm going to do is I'm going to find just a kind of a blank clear spot on the drawing, and I'm going to hit my DP button, and I'm going to go out there and left click just in a blank clear spot of the drawing. You're going to get a little preview circle. That little preview circle, it's going to honor whatever the current settings are as far as how it looks and the line thickness and so on. So I'm hitting DP, click a little dot out there. It's going to read whatever your current settings happen to be. It's nothing that's going to stay in the drawing. I believe we'll find out that is going to be the bottom left-hand corner of the profile view. We'll know in a minute. It does let you pick here what view number you want to place this in. And then once we do have a profile, there's a little icon that would let us center the profile on our screen. That's that little tiny icon just to the left of apply. If you look at the upper left corner of the dialog, there's a file menu. There's a lot of items and a lot of stuff to set up on this profile tool. So you always want to take advantage of this file menu. You can click File, and you can pick Save As, and you can save this profile preferences file, and then you can reload it later. So on this dialog box and almost any of the more complicated dialog boxes that GeoPak has, there's usually a file button where you can do a save or save as and reopen that file, so you're not reinventing that whole wheel all over again. Scale-wise, we're going to have let's make ours not a 10:1, but a 5:1. So we're going to have a horizontal scale of 10 and a vertical scale of 2. The stationing is going to be filled out automatically depending on which nodes we're picking. So if we pick S200 up to S211 out, that's going to be 545 feet. So the stationing, that's not anything you can change there. You can specify the minimum and maximum elevation. I don't recall exactly what these are, but this is probably about the right range. We can always adjust that as needed. We can, if we had a TIN file and we want to plot that as our reference surface, we can. So if you'll toggle that reference surface to TIN file, and we will pick our SR61 final.10. So that's our proposed surface. You do have a vertical offset that you could apply to that. That's not what we're wanting. We're wanting to just have it represent the proposed surface out there. So we have 0 or no vertical offset. And then if you'll click on the next tab, which is display, this is where we can pick what we want to have drawn, or part of what we want to have drawn. So we can display the soffit. That's the top of the pipe. And then we can double click here and pick what level, color, line weight, and style that we need. Now these profiles here don't typically necessarily have to follow any of the CAD standards, because these are generally used for analysis and we're not doing plans production here. If we're plotting this on top of a roadway profile where we're later using this identify profile cell, we may need to take some more care to go in and set all of these items to proper CAD standards. And that does take some time, and that's where you want to use that file save as, and you don't want to have to redo that every single time. All right, so the soffit, I'm just going to double click here. We'll let that go on the default level, and I'm just going to have it light blue and a weight of 2. You pick whatever you want for these. I'm not going to plot the pipe center, but I am going to right click and copy the soffit over here to the invert. So I'm just doing a copy and paste right over those little preview windows. Design surface, really we've already picked that on the first tab, so we can skip that. The reference surface is what we picked right here. So I'm going to set the reference surface to be an orange color. Now maybe I'll make that a dashed line. and I'll make it a weight of maybe 1. The original ground, which ties all the way back to the project preferences, I'm going to set that as green, and I'll make it a green dashed line, which is kind of our standard for existing ground. We don't have any waterline crossings. Let's toggle on drainage crossings. We're going to set that to red and maybe a weight of 2. And we don't have any sewer line crossings. And we'll set up the miscellaneous utility crossings in a second exercise that we run into in this chapter. For the waterline crossings, it does have a separate label. Same thing for drainage crossings, sewer, and miscellaneous utility conflicts. So I've only checked on drainage crossings, and I'm just going to do a quick copy on that, and then check on label and right click and do a paste. And I'm going to make that, I'm just going to make it a weight of 1 for the text. That way it's not too thick. And then we'll move to the drainage information tab. And definitely we want to go ahead and plot the hydraulic grade line there. And pick a color I haven't used. I'm going to make that yellow, a weight of 2, and some type of dashed line. You can also plot the maximum soffit, so the maximum top that the pipe would be. You can plot the minimum invert, minimum cover, and maximum depths. We'll plot those so we have some more out there. I'll probably make all of those the same. And let's say those can be kind of a gray. And there'll be dashed lines. And I'll leave them at a weight of 0. So I'm doing one of these. And then I'm cheating. I'm right-clicking and saying copy. And I'm going to the other ones and right-clicking and saying paste. I don't want to have to double-click there 4 times and set them up individually. And then we'll add the drainage node. And I'm just going to make that the orange thick weight like we've had previously. And you're not, just because we create this profile doesn't mean that we're stuck with these settings. As long as we leave this dialog box open, we can check and uncheck items on the fly, hit apply, and it'll automatically go ahead and update that profile. So if we end up with some items we don't like, we can get rid of them pretty easily. The grid and labels, we'll go ahead and put nodes. Let's see here. Oh, to activate these, you have to double click on them. Let's see if you... And that's true even if you are trying to click in that little tiny box there. So I thought you could click in the box and put a little check mark. That's not how it works. You have to single click in the box, won't work. You pretty much have to double click on all these. And then we'll set them up. So you can see where if we were being very specific with this dialog, we could easily take half an hour to fill out all of the stuff. So definitely take advantage of, when you're doing this on a real project, take advantage of doing a file save as, save it in some generic drainage folder that you have so that you can retrieve it later. There's no need to do any of these twice. For my nodes, let's see what we got here. Label offset. I'm just going to say library item name. And I'm going to leave the text as it is. We might have to tweak these. The link label, I'm going to label the length, library name, the slope, and the link name. And I'm going to pick this little button here that says stacked. That should stack those elements or those names, the link length, the library name, link slope, link name, should stack them inside of the pipe. We might find out that they're too small or too big. It might be too crowded. We'll fix that as we need to. Elevations, we'll plot the invert elevations, and we probably don't need elevations at intervals. So we'll just plot the invert elevations. And we'll let that vertical offset just be 0. The grid boundary, we'll just leave that at the default level. We'll make it a weight of 1. And then for the horizontal grid, we've got a major interval of 50. That should be okay. We'll put in a minor interval of 10. And then for the vertical grid, we're going to make the major 5. And we'll make the minor 1. And this may just flat out end up looking way, way too busy. And we can adjust it as needed. So I'm going to go ahead and do a file save as. I'm going to put this in my drainage folder. And I'm just going to call it profile. All of these file buttons on these busy or more complicated dialog boxes, they're all going to have a weird extension. So this one's going to have a .ppf extension. What I would do in actual practice is I probably would not save this in my actual project folder for drainage. I would have some drainage folder out there that had various preferences in it, and then I could just reuse those for each project. But since this is really all we have here for now, we'll just save it in the drainage folder. So I'll just call it profile. And then once all these items are filled out, the link profile is actually where we can edit some of these items. And it does recompute the network, so we're not really touching anything there yet. And we're just going to go ahead and hit apply. Now what you're going to find is you're going to find that this profile tool is always set up so that your drawing is unrotated. So your profile is going to be extremely crooked looking. And that's because this drawing has been rotated so that we could look at the stations left and right here from 700 to about 705 or so and have it more readable. So what you're going to need to do for your profile to look better is go up to your rotate option here, rotate view, and then go ahead and pick unrotated. And that should straighten out your profile there. Now, if this grid is a little too much, you can always go back to grid and labels and turn off maybe the minor intervals for horizontal and vertical. Hit apply again. That's going to clean up the view quite a bit for you. If you find that the text is a little too small or too big, you can adjust this however you need to. And then once you've got it like you really want it to be, just do a file save as, and you can overwrite that profile file that you made. So I turned off the excuse me, the minor intervals on horizontal and vertical grids. So drainage information wise, my hydraulic grade line is this yellow dash line right here. Now I am not a drainage engineer, but one of the main things you're looking for is you don't want this hydraulic grade line ever higher than the top of any of the structures. And you can almost think of this as the water level. And if that's incorrect or there's a better way to explain it, more than open for suggestions. So looking at this, it looks like it's probably okay with these 18-inch pipes that we have. We're probably good to go. Now, I am told that the way that GeoPak Drainage plots this hydraulic grade line here where it hits the structures is really not correct. It's actually showing like a hydraulic jump. So that part here is not exactly correct. But if you see this hydraulic grade line coming out of the top of one of these structures or out of the tops of the pipes, that's where we're going to have a problem. We can plot also our uniform depth, our NEG grade line. I'll just add the uniform depth here by doing a copy and paste. That's going to be real similar to the hydraulic grade line. I believe that's actually the water level that you have. So when we went through and we ran this first pipe here and set it at a 12-inch size, that's probably why it was okay. 12-inch size was probably fine for that, because we're barely, we're hardly filling up, we're hardly using even half the capacity of that pipe. The 12-inch pipe probably was fine. And there should be, let's see if I can get to it here. It should have a full description of all these different options in the GeoPak drainage help file. Let's see what we have in there. So I'm going here to GeoPak drainage and then help. And then we'll go to command reference here. And we'll look at component. We're going to look at profiles. And we'll look at our dialog. Let me make this a little bit bigger here. And we're going to look at the drainage information. Yeah. So I think your uniform depth is basically your water level. You'll see that it's pretty close to the hydraulic grade line.